Hello everyone, welcome to this KANPUR-NPTEL online course on space environment and its effects on orbital spacecrafts. So, in this week we are discussing a very few important topics which we will refer very frequently when we discuss various types of spacecraft environments. And currently we are discussing the sun and its activities. So, we discussed what is the different solar activities in terms of the sunspots, which is related to activities like coronal mass ejection, solar flare, solar energetic particles. And in the last class, we were discussing about the we started discussing about the interplanetary magnetic field. So, in order to explain the interplanetary magnetic field, we need to know what is the structure of the atmosphere, that is the outer zone of the sun, that is the corona. So, the topic of corona, we studied what are the coronal structures. So, we have seen the different types of the magnetic structure, that is open lobes, then closed lobes, we call it the helmet streamers, then pseudo streamers, then coronal holes. So, these are the then coronal loops, helmet streamers, coronal holes, these are the things we studied, which are very important to understand the behavior of the magnetic field in the corona. And you know, the corona, at the corona region, this plasma particles, they attain a temperature of something like 1,000,000 degree centigrade. So, what happens after that? We will just continue. Yesterday we started discussing the interplanetary magnetic field, and we will continue from there. So, we will see what is the behavior of the interplanetary magnetic field, and then we will study another very important topic, that is the co-rotating interaction regions, or it is also called CIR. So, what is interplanetary magnetic field, or it is also called the IMF? So, it is the magnetic field that exists in the space between the planets within the solar system. So, basically the magnetic field what you have seen in the coronal regions, so they are swept away throughout the solar system, or you can say it is the throughout the heliosphere, until unless it is coming to a it is a heliopause, where you know that intensity is too low, or it can interact with the magnetic field of the planets. So, what happens? Component of the solar magnetic field, so that is dragged out from the solar corona by the solar wind. So, how does it happen actually? How this solar wind, it drags the component of the magnetic field, and it is to the flow towards the solar system. So, in the solar corona, the magnetic pressure that exceeds the plasma pressure, means whatever the plasma having the own its pressure, and what is the pressure created by the magnetic field. So, as you know that whenever any charged particle is moving in a magnetic field, a force is exerted on it, and what happens because of that force, the charged particles gets trapped in the magnetic field. It starts gyrating across the magnetic field, with the magnetic field being the axis of the gyration. But here what happens, when the altitude through the corona it increases, then the solar wind accelerates. How it gets accelerated? Because it extracts energy from the magnetic field through the Lorentz force interaction. So, what happens because of this? The flow momentum it exceeds the restraining magnetic tension force, and as a result of this, the magnetic field is dragged out by the solar wind from the IMF. So, this is one aspect. The another aspect is that this magnetic field, it is stick to the atmosphere or the structure of the sun, but the sun rotates or revolves about its axis. So, because of that thing what happens, this magnetic field, it is pulled into an Archimedean spiral pattern, and that this is called the Parker spiral. So why Parker? Because this is the scientist who put that theory that there is an existence of solar wind and this interplanetary magnetic field, the concept of the spiral type of the magnetic field, that is called the Archimedean spiral pattern. So, we will see how it is. So, you see this is the magnetic field, and this magnetic field it is rotating with respect to the rotation of the. So, this is the rotation. So, with respect to the rotation of the sun, as if it is co-rotating with the rotor. So, magnetic field as well as the solar wind and the magnetic field, and the magnetic field is frozen in the solar wind. So, both of them are rotating. So, this is the magnetic field is co-rotating, that is why it is called the co-rotating magnetic field. The source of this image. Now, this we can this whatever this sort of thing, that is the rotating, that is whatever the charged or this whatever the solar wind flow is there, that is as if it is churning or it is spiraling. So, that can be understood by so this is a sprinkler or using the water jet, which is used for the watering the garden. So, you can see here this water particles, they are it is forming this spiral. If you see it in one plane, here also this is shown in one plane, it is just in the elliptic plane. So, it shows in a 2D diagram. So, but basically it will be this magnetic field will have a a 3D structure, that field configuration will be a 3D structure. So, this you can you can compare this is that this water, there is the flow of water with this the solar wind flow. So, again here since the sun is rotating here, as I already said, because the sun is rotating with 25 days period at the equator and 27 days at the polar. So, solar wind flows out radially with magnetic field frozen in it, which we have seen in the earlier schematic. Since the magnetic field lines is tied to the sun, so the rotation results in the spiral magnetic field. It is radial, but it is making a that configuration becomes the spiral, and the resultant field, it looks like a lawn sprinkler. So, whatever they use in the lawn. So, it is basically a water jet escaping from a rotating carousel. So, that already you have seen in the previous schematic or previous image also. As already I said, that is Eugen Parker, he theorized this in early 1950s. Of course, initially people did not agree to his theory, but subsequently his theory proved by the various the experimental data, it was proved to be whatever he was saying is correct. So, this shows, so here in this diagram we are showing it from this, this is the the coronal magnetic structure and how it is coming out. So, here this red magnetic field, the red one, it shows it is the magnetic field coming, out from southern hemisphere. So, and this part is the magnetic field from the northern hemisphere. Okay. So, here you see the magnetic field is represented, the magnetic field is always a vector. So, it shows the three components. So, you can consider it like a spherical coordinate system. So, having a radial vector, then having an azimuth, this is the phi vector, and then an elevation vector, this is the theta vector. Similarly, the velocity vector also shows. So, here this B is expanded, this velocity vector as well as the magnetic field vector as well as the velocity vector are shown as a component of the 3 components in the spherical coordinate system. So, as I said, so this is shown it is in a plane. So, this is called the ecliptic. Ecliptic means this orbit of this like the orbit of the sun or the planets where is moving revolving around the sun. So, this is the ecliptic. So, you have taken this shows a one cross section or one cut in this ecliptic plane. So, basically the magnetic field and this whole thing is forms a basically it should be 3D and which is shown here. And here this you see yesterday I said whenever there is a magnetic field. So, the polarity of these two magnetic field, this is our so one is the coming from the southern thing and the other is the northern. So, it will have this type of this polarity is different. So, when there is two magnetic fields having the polarity is different, there has to be a current sheet in between, that is by the Ampere circuit law. So, whenever there is the current, so there is a the magnetic field and the magnetic field these two lines. So, the basic between this positively polarized magnetic field there has to be the current sheet. So, this is heliospheric current sheet, HES means heliospheric current sheet, I will write it here, HES means heliospheric current sheet. Okay. So, at the orbit of the earth, so this interplanetary magnetic field now it has driven away from the this coronal region of the sun and then it is going into the interplanetary magnetic field. So, once it reaches near the earth, so what happens at the orbit of the earth, the interplanetary magnetic field makes an average angle in the ecliptic plane of approximately 45 degree to the radially outward directions, that you can see it here. So, this is the ecliptic, this is the orbit of the earth. So, you can see the magnetic field, they are so you can see this, if you draw a tangent here, so this angle is 45 degree, that may not be exactly 45 degree, again it depends on the what is the solar wind, the magnitude. So, depending on that thing, but in average you can say this is like a this angle is 45 degree. And again here the magnetic field lines, that is that earth's magnetic field lines and this field lines, they will have this direction, that is earth's magnetic field as well as that interplanetary magnetic field, we will come to that thing. So, this is called the southward or the northward, that we will explain one by one. As I said, this observed angle is it is due to the rotation of the sun which the IMF is anchored. Okay. So, the angle of the interplanetary field with respect to the magnetic field of the earth, it plays a very key role in determining the level of geomagnetic activity. So, in our subsequent sessions, we will discuss what is the geomagnetic activity because of this impinging solar wind or the high energy particles from the sun. So, we will define the terms like geomagnetic storm, geomagnetic substorm, and we will tell you how those effects, that is the geomagnetic storms, it affects the space weather as well as interaction with the spacecrafts. So, geomagnetic activity, that is caused by the interaction of the solar wind with the earth's magnetic field. This is also a topic we will discuss a little bit more detail in the subsequent classes. The form of this interaction, what should be the interaction? It will be controlled by the interplanetary magnetic field. So, when the interplanetary magnetic field is northward. So, northward is we are saying is with respect to that is our if you consider the earth as a magnet. So, there will be the south pole and the north pole. So, generally the what is the geographic north pole will be the magnetic south pole and geographic north pole will be the magnetic south pole. So, the magnetic field lines that starts from the north pole and it will end to the south pole. So, that direction is referred here, whether it is a northward or it is southward. So, when the interplanetary magnetic field is northward, the disturbances are observed only within the polar cap. So, again this needs to be a explanation when we will explain the that is the Earth's magnetic field, that is or the magnetosphere, that we will have the scope to explain these things, but just I will tell you in short. So, you can see here this in the polar region, the magnetic field lines are very much stressed, there the density is very high. So, that region is called the polar cap, and here this phenomena that is called the aurora, that is the northern or the southern that is the aurora, the polar aurora. So, this thing comes here. So, when ever this IMF is northward, so you can see the disturbances observed only in the polar cap. So, it is only where this the magnetic field is within the polar region where it is very dense, whereas the southward this creates the magnetic disturbances in the aurora, and it is in the auroral oval. So, generally that we will see that this is also we call it the magnetic substratum. We will explain it in the subsequent sessions. So, what is auroral oval? It is the footprint of the atmosphere of the boundary between the highly stressed magnetic field lines of the polar cap, the normal field lines at the lower altitudes. So, those regions where we see this aurora, or so this is called the auroral oval. So, stronger the southward component of the IMF, the stronger is the disturbances. So, this coupling of the solar wind to the geomagnetosphere is brought about by the process of magnetic reconnection. Just we will see in the next slide. So, already you know what is magnetic reconnection. Whenever two magnetic field lines they are stressed and they are having the opposite polarity. So, that magnetic when they touch, so the snapping occurs, and as a result of this the topology changes, and through that what happens, the energy stored in the magnetic field, it is transferred to the energy or the kinetic energy or the thermal energy of the charged particles. So, now let us see what are the IMF components, because already we have seen this magnetic field is always a vector. So, it will have the components. So, first we will consider this total value, that is BT means the total value of the interplanetary. So, what is BT? BT value of the interplanetary magnetic field, it indicates the total strength of the interplanetary magnetic field. It is a combined measure of the magnetic field strength of the north south, east west and towards the sun versus away from the sun directions. So, the higher this value, the better is the enhanced geomagnetic. So, a moderately strong total interplanetary magnetic field when BT exceeds 10, and this T is Tesla, T means it is the Tesla. The strong value starts at 20 nanotesla, very strong total interplanetary magnetic field when the values exceeds 30 nanotesla. Now, we will see it the coordinate system of it. So, there we are using the Earth's coordinate system. So, what is the coordinate system? So, we consider this is the magnetic that is z axis is the line which connects the south pole and the south magnetic pole as well as the north magnetic pole, north to south. And what is the x axis is the line which it is called the line connecting to the earth to the sun. So, this is the x axis. So, the magnetic field in this direction we are calling it the Bx, and the magnetic field in the direction. So, we are calling this at the z axis. Z axis means this is the axis which connects the magnetic north pole and the south pole, and the Bi will be so it will be perpendicular to both the axes to make it as a right handed system. Now, if you see the Bx and By will be in the ecliptic plane or in the orbit in which the earth is revolving. So, okay. So, Bx and By are oriented parallel to the ecliptic. So, they are in the plane of the ecliptic. The Bx and By components are not important for the conflict to the earth's magnetic field. So, which one will be important? The important one will be only the z component which will interact. So, Bx and By will not interact, because the structure of the Earth's magnetic field in such a way, so that this will be this Bx and Bi will be if you see the magnetosphere. So, basically your the Bz component will be important when I consider the magnetic reconnection. So, that will happen only with the Z component of the magnetic the interplanetary magnetic field. So, the third component, that is the Bz value, which is perpendicular to the ecliptic, is created by waves and the other disturbances of the solar wind. Yeah, in fact, all these components are due to that only. So, now we will see what is the southward IMF. So, southward IMF means it is geographic. If you consider this is the earth, this is the north, this is the south. So, it is coming from north to south, whereas the earth's magnetic field it will go from the north, that is this is the magnetic north pole and this is magnetic south pole, and geographically this is just the opposite. So, what happens, you see this is the point. So, you are having a magnetic field, two magnetic field lines, one is in this direction and the earth's magnetic field is this direction. So, this will create, because of this solar the wind pressure. So, what will happen, this because this will the touch, and that what happens, this is the reconnection happens. So, this is one the reconnection point, whereas this the whole the magnetic field, that is the Earth's magnetic field magnetosphere, it is a little pushed back towards the tail. So, there is another reconnection point. So, this is that point. So, there are two reconnection points here because of the southward interplanetary magnetic field, and this it plays a huge role in how the solar wind interacts with the Earth's magnetosphere. The north south direction of the interplanetary magnetic field Bz, this is the most important ingredient of the auroral activity, that we will see in our when we discuss the magnetic storm, geomagnetic storm and substorm, we will discuss those. So, when the north and south Bz of the interplanetary is oriented southward, it will connect the Earth's magnetosphere which points northward. So, this already I said. So, if it is strong, it can create a havoc with the Earth's magnetic field, disrupting the magnetosphere, allowing particles to rain down to the atmosphere along the Earth's magnetic field line. So, this is actually called, I will just note, this is called the geomagnetic storm. Though we will have separately we will discuss this, but this is the reason when a southward IMF if it is strong, then it creates this type of disturbances. And this also shows here the reconnection. This diagram is just to show you how the reconnection happens. So, at the day side, so this is the day side, this is the night side. So, you have seen there are two the reconnection occurs at two plasma regimes. So, this is because of this the southward IMFs. Okay. And this already the reconnection occurs in the small region where the plasma becomes demagnetized, creating open magnetic field lines. Okay. So, you see where this IMF magnetic field and opposite to the north directed intrinsic magnetic field. So, because of this they are of the opposite direction, because of that the reconnection happens. So, this is the location, this represents the first point of contact of the shocked solar wind flow, and it is embedded the magnetic field against the Earth's compressed magnetic field at the magnetopause boundary. So, this is the magnetopause boundary, magnetopause, MP means the magnetopause. So, if you see this northward IMF, so here this both the magnetic field are having the direction is the same. So, if you see when it is moving, then it is not directed, and the Earth's, that is the intrinsic magnetic field also it is the same direction. So, here the magnetic reconnection is not happening here, but it is happening at this region. You can see this is the 2 points M1 and M2, and this creates that is already I said. So, this you will have with this charge, it will that because of this reconnection, the charge will be accelerated and it will move towards this polar cap. So, there are two magnetic reconnection sites. This is the point M1 and M2 that already we showed in this diagram. So, this is also called the cusp reconnection or the lobe reconnections, and this happens at the or high latitude reconnection also. Now, one more topic, that is called the co-rotating interaction region. So, co-rotating interaction region, already if you remember in the last session I told, then whenever in the coronal holes where the magnetic field lines are are open. So, this is not the closed loops. So, there the solar wind or will have the higher energy or it will be faster. Whenever the regions where the coronal holes are there. So, from those regions whatever the solar wind will come out. So, that will have the higher velocity as compared to the surrounding. So, because of this two regions there is a region, it is called the co-rotating interaction region, and this also rotates along with the because of that sun's rotation and the magnetic field, that is the spiral nature of the magnetic field, these also rotates along with this. So, CIR develop when the high speed solar wind typically originating from coronal holes catches up with the slower wind streams. And there are two types of the forward pressure or the shock wave at the leading edge, and the reverse pressure wave at the trailing edge are generated. And at greater distances from the sun, these pressure waves can develop into shock waves. So, these structures produce regions of enhanced density and the magnetic field strength in the solar wind near the ecliptic plane. So, because of because of this three dimensional structure of CIR is influenced by the sun's magnetic field configuration, and because the sun's magnetic equator is often tilted and warped relative to its rotational equator, CIRs typically show significant north south tilts that differ between the hemispheres. And the forward waves tend to move towards the solar equatorial plane as distance increases, while the reverse wave propagates towards the higher latitude. So, these two waves, co-rotating interaction regions. So, both the forward and the shock the reverse the shock waves, they propagate once towards the solar equatorial plane, and this the reverse wave toward the higher latitudes. And so, that is why the CIR play a very important role in the space weather, and the heliophysics will study it. So, it can trigger geomagnetic storms, that which we are going to explain what is geomagnetic storms when they reach earth, and they introduce distribution of energy particles in the heliosphere, contributing to the modulation of the cosmic rays, particularly during the periods of low solar activity, and cause compression of the interplanetary magnetic field. So, this is another this is the effect of this. So, this whatever I discussed, thus is shown it through this two cartoons. So, here you can see this is the fast wind regions and this is the slow wind region, it shows here the fast wind. And so, because of this interaction, this is that interaction region, this region. So, here there is a forward wave and there is one this first wave. So, first wave is moving towards forward one, and the first one is moving toward the equatorial region. So, I will end here, and in the next session we will go to this how this magnetic field, that is the interplanetary magnetic field, is coupled. I have discussed today a little bit, I will discuss in more detail in our next session. Thank you very much.